We're just recording this for your own purposes later. Okay, what would I do first? I would draw myself a T-chart. Hopefully a good T-chart, right? What would I put on the top here? Statements, right? Always on the top is statements. And on the other side, we're going to label it with, Hassan, reasons. Okay? For my purposes, I'm going to pretend like these aren't here. You can follow along in your book, but we're just going to uncover these as we go along. All right? So if I look at the actual diagram here, we would know and we would see like that I have actually just have a triangle, right? And all we did was take our triangle and extend out one of the sides to create this exterior angle. So what do we know about these angles in the triangle? See? They add to 180, right? And so the reason they add to 180 is just like if we were talking in class, we would just say the angles of a triangle add to 180. The angles of a triangle add to 180. That's all you have to put down, okay? That's it. Now, besides that, what's going on with we extend this line? What else could we also know by extending the line out? Emily? Okay, we're going to get there. But if we were to, and if I was just to do this, right, and get rid of this stuff, what do you know about those angles? Good. So I would just say, okay, that angle W plus angle Z is equal to 180. And those little M's in front again mean the measure of those angles is equal to 180, right? And what's the vocab word that talks about those two angles like that? Fahim? So a linear pair of angles add to 180 or are supplementary. That's it. Okay? You guys see how we talked about the vocab? It's important to recognize when to use it here. And now this is the big thing for today. This is it. This is the main thing you should walk out of here knowing. Grace, what do we notice about these two equations? What's the same about them? What's at the end of both of the equations? They both equal to 180. So if these two equations are equal to 180, just like in the old systems of equations, right? If two equations are equal to the same thing, I can and say that they are equal to each other, right? I can set the equations equal. So in the next statement, all I did was say angle x plus angle y plus angle w is equal to w plus z. Okay? The technical reason we're going to use today is called the transitive property. Okay? Now, you can also use substitution. So if you forget transitive, just remember you can also use substitution. What does transitive literally mean? If A is equal to 8, right, and B is equal to 8, what do we know about A and B? They're equal, right? And a lot of times, instead of 8, what you'll see is you'll see like C. So if A is equal to C and B is equal to C, since they're both equal to C, they're equal to each other. A is equal to B, okay? That's what transitive, it's like setting equal, that's it. Make sense? Okay, now, Etha, what's the same, what do you notice is the same in these two equations here? They really just both have the measure of W, right? So if I wanted to get rid of the measure of angle W, what would I do? Yeah. And what's the property called when we subtract the same thing from both sides of the equation? That's right. And if angle W goes away, we get left with angle X plus angle Y equals angle Z. And the reason is just the subtraction property of equality. That's it. This is your proof. We're done. Okay? So we now have shown why this exterior angle theorem works. Does this make sense to you guys? The big thing for today, though, is that if what we're going to do is to do the questions today, we have to create equations that are equal to the same amount, We have to set them equal to each other and then look for something that's the same in both and subtract it away to get a result. That's our proof statement. Does that make sense? You see the process? That's the big process for today moving forward. Okay, let's take a look at a proof using this concept on the next page. So flip on over and let's take a look at exercise 1-6 here. And you know what we're going to show? We're going to prove that the vertical angles are equal. We're going to do a proof. So what we're going to do is right in this little area right here where we have a little gap, let's go ahead and make a T-chart. I'm going to move my line a little bit left. Okay? And on the top of the T-chart over here, we're going to write statements just like we always do. And on the other side, we're going to write reasons. All right, you guys are on the game here. Okay, I'm going to create a statement for us. And what I'm going to do is I'm going to call this line, this first line right here, I'm going to call that L. And the other line we're going to call, what do you think? J. All right, let's call it J. And it's kind of like a cursive writing when you want to write. So I guess I should write J, right? So lowercase cursive letters are usually what the lines, the name of the lines represent. So for our first statement, we're going to write, lines J and L intersect. That's our drawing. And the reason is, first reason's always, Kara, first reason? Given. Perfect. Heard it over here too. Awesome. Easy enough? Okay. So, Orna, let's look at this little first dot here. What do you know about angles W and X? In that picture. Now, careful because we don't have the parallel line deal, right? So we can't really use interior. But that's it. They just add to 180, right? Is the same thing true about Y and X? Okay. So we're going to put down, right, that those angles add to 180 degrees. Make sense? So this is where we're going to get our equations. So the equation we can make, right, is we're going to say that angle W plus, what's the other angle? X, and that equals, well, remember, before that, that just equals, remember what you said, 180, right? Got to start with that equation first. You're already heading down that road where we're going, though. Perfect. Okay. Why is this true? What vocab word or description can you give me to say that that's the case? Who's got it for us? Oh, Lena looks like she's got it. What do you got, Lena? Vocab word describes angles W and X here. Or just why would they make 180 degrees? Right? After I looked over at you, it was like, why? How do you know those add to 180? You would just say they make a straight line, right? Or they make a vocab word starts with an L. Linear pair, right? So I can write down, and if you guys forgot, remember page 12. Oh, wrong one. Scrolling down for no reason. Page 12 over here in our packet, right, has that cheat sheet of fun, okay? And if you look for the drawing, oh, it's right there, right? Linear pair of angles adds to 180. You can just put that down. So that bold underlined statement right there is our reason. So we're just going to write down linear pair of angles add to 180. Can anyone think of another reason, another vocab word about 180 degrees? Aaron? You could just say the supplementary angles add to 180, or angles on a line add to 180. Any of those fine. They're all fine, as long as it's mathematically true. Okay? We said we're going to write down linear pair of angles add to 180. Perfect. Okay. Zach, what about angle Y and X? What did we say about those again? Okay. Do I need to make a new statement and a new reason for this? Do I need another reason? Zumar, what do you think? Do I need a reason for this, or can we just use that one? Use it? Me too. So all we're going to do is if you're going to make a new statement with that same reason, just put a comma and like put it in that, throw it in with number 2. Okay? If you want to create a new reason and call it 3, go for it. Just write it twice. Okay, now remember we talked about. Once I get 2 equations that equal 180, Matt? Yes, so we're going to write down angle. Yep. Plus angle X. Perfect. Equals angle Y plus angle X. The reason for that when we set them equal to each other again? Just like the charts of the T. Aaron? Transitive property. If we forgot that, remember we could say substitution. But transitive property works here. All right. So far so good. And Genevieve, what do you notice about this equation now? How do we get from this equation to getting W equal to Y? What's going on here that we can? Yes, we can subtract X, right? So if I subtract X from both sides, we'll get left with angle W equals angle Y. And what's the reason we were able to do that when we subtract X? We would say, that's right. Subtraction property of equality. Nice. Okay. Easy enough. Are we done? Did we set out to prove what we wanted to? Did we show that these vertical angles are equal? Yeah, W equals Y, right? So we're done. That's it. Okay. That's the proof. Do you see the concept though? We created 2 equations that were both equal to the same thing, right? We set them equal to each other, and then we took away what was the same on both sides to get left with our result. That's it. That's the theme for today. Okay? Cool? Cool enough? Very cool. Mr. Z, wrong word to use there? Okay. Let's go down to the next page here, and we're going to do number 3. Number 3. So once again, we're going to, oh, too far. We're going to do a proof, so we need to make a T-chart of fun. Sophia on the top left, we're going to put, and then, nice. Good deal. Okay. Now, for this one, we're just going to use what they have written here, which is the diagram to the right. So we're going to write, the first statement is the diagram to the right. And our first reason we're going to write is given. Okay. Normally, there's be some sort of description. It would be like triangle WXZ with line YZ drawn, something like that. Okay. We're going to use what we got here. So our job is to prove that angle Y plus angle Z is equal to W plus X, angle W plus X. These 2 angles are the same as when we add these 2 angles. Can anyone have any idea based on the diagram of how we're going to do that? Zach? What do you mean they're going to equal 180? I love where you're going. You're heading the right direction. Well, not y and z together. Y and z are actually part of what figure, Matt? A triangle, right? So y and z would add together to 180 if we also include what other angle? A, good. So for statement number 2, we're going to write angle y plus angle, what's the other angles again? Z plus angle, and that's equal to, and what's the reason, right, Matt? What did you notice that let us do that? Well, just break it down. Because they're part of a what shape? A triangle. So we would say Z, Y, and A are all the what part of the triangle? The angles. So the angles of a triangle. We can use the little picture. And what about them? Good. Add to or equal 180. There's our reason. We're good. Grace, how are we incorporating W and X here? Oh, another triangle, right? This outside one is also a triangle. So what equation, Grace, can you create now? All right, I like it. Are also equal to 180. Do we need a new reason for this? No, it's the same reason, so we'll just put a comma there to put those together. So far, so good? And Bentley, now that we have these two equations that are equal to 180, what do I want to do with them? Yep, the transitive property. And what does that let us do, though? Good, angle y plus z. Okay. Good. So all we're basically doing is just setting the equations equal. Perfect. We can set those equations equal to each other. And Emily, the reason why we want to do that, we can subtract a, and does that get us our proof statement? Yeah, right? What does it get us? It gets us angle y plus, good. What if yours, like if we didn't write these in that same order, if these were just mixed up a little bit, like it said z plus y, would that be okay? Yeah, it's all right. As long as all those angles are there, we're good. And we would just write down what? Fahim? Nice. Subtraction property of equality. All right. That little bell means the 5-minute warning. No, I'm kidding. It means I got an email. But it's the 5-minute warning. How are you doing, Genevieve? All right. Yeah, I'm doing okay. Pretty good. Friday, halfway done ish, right? Plan words there ish. Here we go. Um, let's go to the homework. The homework tonight is on page 9 in your notes. Let's just start these questions so that all you're going to do for the homework tonight is fill in just this page, page 9, not page 10. We're just going to fill in the blanks, okay? I'm going to help you out with just the start of these couple questions, and then let's see if you can go from there. You guys ready? Okay. So if I look at the given, right, this given is just technically two angles. We could say angle PQR, we'll put a 1 here, and angle RQS, angle 2, right? When I combine these angles together, what does it really form? What does it give me? I thought if I were to add angle 1 and angle 2 together, what does that make? I see you tracing it with your pencil right now. What are you tracing? Sort of, right? Drop the try part. An angle, what is this angle? This is angle Yeah, PQS, right? That's PQS. So if I add two smaller angles, right, that create this angle, you would agree that 1 plus 2 should equal this big angle right here. This is called, and on your note sheet, it's the second one on page 12 there. It's the second one on the left, but it's segments there. This is just angle addition. So we're going to write down, you can either put definition of angle addition. You guys want to write that? We'll keep it like the same. So we'll put definition of angle addition. The one in your notes is segment addition, right? If you add two smaller segments together, you would get a bigger segment back, okay? You're just adding the angles. Sometimes you might see angle addition property, but definition is also fine. Cool? And then you should know what we're going to put down for number 2. Fahim? Okay, I'm going to stop there and let you guys finish this for homework. Okay, but Fahim said that's substitution, and he's right. We're going to jump down to number 2, though. So let's just take a look at 2. So I started you off at number 1. You guys should be able to finish number 2. All right. Now, when you're doing a proof, you're going to really want to pay attention to the givens to get you started. So is there anything in the given that stands out as like important? Any vocab or anything here you see? Devante? How do you know they make a right angle? Well, there's a symbol here we're looking at. Aaron? Careful, too much. Nope. Nope. Perpendicular. Remember, that upside down T is just perpendicular, okay? It doesn't necessarily mean that it cuts it in half. It just creates 90 degrees, okay? Now, on your sheet, if you guys are looking at page 12 here, okay? Oh, right to the right over here, perpendicular lines create 90-degree angles. That's the reason for that one. That's it. Okay, I'll put it on here, and in case you get stuck, you can check the notes later. Perpendicular lines make 90-degree angles, but I hope that you guys have a great day, and then finish up number 3, 1, 2, and 3 for homework. We'll see you guys